Hello, this is Dr. Mears, and today we're going to be solving trigonometric equations, and this is part 2. For these examples, we will need a very important trigonometric identity, and that is sine squared theta plus cosine squared theta equals 1. Now, you've actually seen this before, and I'm going to bring some context to it. So let's make cosine, that side, let's label it side A. Let's label sine side B. Let's label the radius of 1 side C. And what we're going to see here is sine squared is really B squared plus cosine squared is really A squared equals 1 is really C squared. And if you just do a little bit of rearranging by swapping the A and the B, we get A squared plus B squared equals C squared. And we're back at the Pythagorean theorem. So that's how this formula was derived, using the Pythagorean theorem. Now this formula is going to, or this identity, is going to lead us to other variations. So really you only have to remember the Pythagorean theorem because then it can get you to sine squared theta plus cosine squared theta equals 1, which will get you to these other variations. The first variation that you could have is going to subtract out cosine squared theta to bring it over to the other side of the equal side. So here we're going to have sine squared theta equals 1 minus cosine squared theta. So here's another variation of it. And we're going to be using these and substituting in either this part or this part of the equation. So we're actually going to be using these. The next variation, and I'm hoping that you're guessing it, is going to be subtracting sine squared theta. So we have cosine squared theta equals 1 minus sine squared theta. So here are two other variations of that first trigonometric identity. All right, let's see how we use these. Here's our examples. We're going to be solving each equation for 0 is less than or equal to x, which is less than 2 pi, giving our answers to 1 decimal place when necessary. Now, when you see this 2 pi here, what you need to do is grab your calculator so that you can make sure you're in the correct mode. So I press mode and I notice that I'm in degrees and I don't want that. I want to be in radians because that's what they gave me here. So you want to check your mode when you see this all the time. So I am in radians, so I am good to go. There's the bell. Sorry about that. All right, so what I'm going to do is I'm going to write each variation of the formula up on top of my paper so that I can refer back to it and not have to flip papers all over. So there's the first one we did. There's the second one we did. And there's the third one. Okay, so we need to solve. That means we need to find what our x value is. So when we have for part A, negative 2 cosine squared x minus sine x equals 1. Now I notice we have a square value and a not square value. I'm going to want to change one of those. And I hope that you start noticing that cosine squared, we're going to be able to actually change that so our square term will be in sine. So these two will be the same. There's instances, and this is one of them, where we want to have everything as sine and not a mixture of sine and cosine. So when you see that we have a square term and these are not the same, then you're going to want to change it. So what I'm going to do is I'm going to use a little substitution. I'm going to do negative 2. Now this is being multiplied by, so I'm going to put parentheses. Cosine, instead of cosine squared, I'm going to be able to substitute this side in. 1 minus sine squared theta. Not theta. Let's use the x term. Here we go. Okay. Sine x plus 1 equals 0. So now you notice I have a square term, but these two are both sine, which is a good thing. Now here comes our algebra skills. We have to solve for x. So first let's distribute this to negative 2. So this is negative 2 plus 2 sine squared x minus sine x plus 1 equals 0. Let's combine some like terms. Negative 2 and 1 can be combined. So now I'm at 2 sine squared x minus sine x minus 1 equals 0. Now, for this part, I'm hoping that you're noticing that we have a square term, we have an x, and then we have a term without it. This is going to remind you of factoring quadratics. So we're going to need to break this up and make it into a multiplication problem. So in this first spot, we have to find what number multiplies to 2. Well, there's only 2 and 1. And how do we get a sine squared? Well, we can do sine x times sine x does give us sine squared x. So you're really treating this like we just have that x value when we used to factor back in Algebra 2. All right. The last term, negative 1, so we need to make sure that we're going to get multiplied to a negative 1. So what I'm going to do here is do minus 1 and positive 1. Now, I'm not sure if this actually works. I have no idea if that works. So what I'm going to do is we're going to test it out. So, get my little paper. So we test it out by actually multiplying. So we're going to multiply 2 sine x times sine x. So that's 2 sine squared x. And then 2 sine x times negative 1, negative 2 sine x. And then the middle, 1 times 1 sine x plus sine x. And then the last, 1 times negative 1, negative 1. So I come away with combining these two, minus sine x minus 1. So I just want to check, is this the same as this? And definitely it is. So I did factor correctly. Okay, now let's go to splitting them up, setting them both equal to 0, and solving. So over here, I have 2 sine x plus 1 equals 0, and sine x minus 1 equals 0. Okay, this one likes to disappear, remember. So let's solve this side. We're going to subtract 1 from both sides, inverse operations. We're left with 2 sine x equals negative 1. Divide both sides by 2, just like we used to do. Sine x equals negative 1/2. Now, we can look on our unit circle for this. That's absolutely fine. And we have to remember that we need to make sure that our answers are in the correct quadrants. So this answer is negative, so it's going to be where the y value, the sine value, is going to be negative. And sine is negative in the third and fourth quadrants. So our answers are going to be between 0 and 6.28 is here. This is 4.71, so our answers are going to be between 6.28 and 4.71, and this is 3.14, and 3.14 and 4.7. So these are the decimals that we're going to have to look for between all those. Okay, sine x equals, if you have your calculator and you want to use your calculator, remember it's inverse operations. So we do second sine, and we're going to do a negative 1/2, and we're going to come out with negative 0.523, so on and so forth. So that's probably the square root of 3. Oh, no, sorry. That's probably pi over something. So it wants it in 1 decimal place. Now I'm talking to myself. It wants it in 1 decimal place. So this is tough because negative 0.5, the 2, we're going to drop the 2, so this is just negative 0.5, and that sometimes confuses people because that's 1/2 as well. Negative 0.5. Now we can't use the negative 0.5. It is in the fourth quadrant because it would be going down. We need positive numbers, so I need to manipulate this to get it in between these quadrants. So what I'm going to do is I think I might subtract 6.28 and 0.5, and let's see what happens. So 6.28 minus 0.5 equals 5.78, and that is in the fourth quadrant, so I'm good there. And then let's do 3.14 plus 0.5 because I want it greater than 3.14. So 3.14 plus 0.5, and that's 3.64. But we have to round, correct? We have to round these decimals. So x is going to equal 5.8 and x is going to equal 3.6. So those are two of my answers. Now we have another half of the problem to do. So we have to add one here, add one here. Sine x equals 1. And so it's positive, so we know positive sign happens here and here. However, we're using the unit circle. So at 90 degrees, our x is 1. So our x is going to equal 1.57. Again, if you wanted to do inverse sine 1.57, oops, not inverse sine, my bad. Inverse sine of 1, you should get 1.57. So either way works. And so since it's on this line, we're not going to have two answers here. We're just going to have this one answer. Okay, let's move on. For part B, we don't have any squares here. Okay, when I look at this problem, I'm thinking that we can turn it into a tangent problem because there's no squares. And how you do that is first you move cosine over by subtracting. So this is 2 sine x equals negative cosine x. This is really a 1 in front, okay? How do we get tangent? Tangent is sine over cosine. Let's write that. Tangent x equals sine x divided by cosine x. So what do we need to do? Yes, we can divide both sides by cosine x. That crosses out. We're now at 2 sine x over cosine x. That equals negative 1. We can change the sine x cosine x to tangent, and then we can divide by 2. So I'm going to flip it up here. So now we're at tangent x equals negative 1/2. And now we're ready to solve. Where is tangent negative? Tangent is negative in the second and in the fourth quadrants. So here's 0, here's 1.57, here's 3.14, here's 4.71, and here's 6.28. And those little handy-dandy charts that I gave you like this, graphs with those labeled, definitely come in handy here. So x equals, we're going to take the inverse of negative 1/2. Let's do that on the calculator. Inverse tangent of negative 0.5. We get negative 0.46. Do we get negative 0.5? Yes, we get negative 0.46. So x equals negative 0.46, but I don't want to use that. I need to get it here. So what I'm going to do is I'm going to subtract 6.28 minus Actually, I'm going to bring down my second, I'm going to bring down my second answer so that I have all the decimals. So I have 6.74. So the first answer is going to be x equals 6.7. And I did that just by subtracting 6.28 minus 0.46. Okay, and then my next one, I want to get it less than 3.14. So I'm going to bring my calculator over. So 3.14 plus I'm just going to use 0.46, everybody, 3.6. And so these are my two answers. Yay! Now I know that I'm hoping some people might say, oh, I completely get it. Now other people might say it is very tedious. It does take practice. So, try your best with this. All right, next one, number 4A. We have sine 2x equals the square root of 2 over 2. And this is going to be between 0 and 360. So again, grab your calculator, change your mode, down to degrees, enter. Okay, I'm good with that. So what this means right here is that we're going to have to find twice the number of angles. So let me show you what I mean. So first, let's do 2x equals, let's take the inverse sine of the square root of 2 over 2. So the inverse sine of the square root of 2 over 2, inverse sine of square root of 2 divided by 2. 45 degrees, there we go. If you just knew that, perfect, 45 degrees. Now, because this is positive, we're going to need it in the first and in the second quadrant, right? 45 is in the first quadrant. Because we have a 2 here, we have to do it twice. So we're going to need 4 answers. So we're going to go around the circle again, okay? So let's get the other answers. So this was 45 degrees. So here we're going to have to subtract 180 and we get 135. So I just did 180 minus 45 degrees. Now we're going to have to go around the circle again. So what we're going to have to do is we're going to have to add, because this is 360. So to get to the next one, we're going to have to do 360 plus 45. And that gives us 405. And so we have this one, we have this one, we have this one. We finally need the third one. And I kind of ran into my thing. So this last one, we're going to take 135 and we're going to add 180 degrees. And that's going to be 315. No, I'm wrong. We're not going to add 180, everybody. What are we going to do? We need to go around the circle again. So it's going to be 360 plus that. This is always going to be 360 when you want to go around the circle again. I'm running out of time here because class is going to start. So that's why my brain is going quick. 495 degrees. Okay, because I have this 2, I have to take each one of these 4 answers, and I have to divide it by 2 to get the 2 out. So 45 is going to be divided by 2, 135 is going to be divided by 2, 405 is going to be divided by 2, and 495 is going to be divided by 2. And after I divide all of those answers, the first one's going to be 22.5, then 67.5 degrees, 202.5 degrees, and 247.5 degrees. And I need you to notice that these are all between 0 and 360 now. So I had to go around my circle by adding 360 to my original. I added 360 to my originals because I had to go around one more time. That's what this means. And then I get to divide everything by 2, and they wind up between my interval. Whew, right? Okay, one more. Cosine x, we have 2 pi. This switching back and forth between the mode is crazy. So we have to remember, push mode here. You might hear the bell. So I'm going to add 1 to both sides here. Cosine 3 theta equals 1. Okay, so 3 theta is going to equal the inverse of 1. Guess how many times we're going to go around the circle? You got it, 3 times. But here's the thing. We're using the unit circle. This is the 0.10. Okay, so 3 theta is going to equal. First, we're at 10 at 0 degrees. Okay, 0. Then we're going to go around. What are we going to do? We're going to add 360 degrees. So then we're at 360. We went around again. Okay, let's keep going around. Then we go to 720 degrees. And that's it. Then we stop. So we had to go around once, add 360, go around, take 360, add another 360. So we went around once, twice, 3 times. That's what this theta means. But I'm not done yet. What do I need to do? Yes, I need to take each of these answers and divide by 3. So theta equals 0, 120, and 240. And so because we divided by 3, these now answers are now, we didn't want degrees. We wanted radians, didn't we? Okay, so instead of 0, 2 pi, and 4 pi, we have to divide these by 3. I see why IB did this. So we have 0, 2 pi over 3, and 4 pi over 3. So these are our answers. Just be careful of degrees, radians. I knew I was going to kind of mess that up, but it's okay. Now you know what the degrees are, which it helps us to visualize what our radians are. Okay, this has been Dr. Mears. I made it. I hope you made it too. Thanks.